Yeah.
You'd have to solve
A
it.
14.
But I'm sure they couldn't give him a 36 because there's no way that they could guarantee that
Yeah.
he
We gave him like a
all-
34.
Like you could guess one wrong, even though you thought you were wrong, but it actually
Right.
wasn't. You were wrong. I'm thinking you were wrong. You know what I mean?
We're accidentally correct. We're accidentally correct.
Yeah.
I get more stressful than make fun of
Oh, you're so smart.
You'd be like, you have to figure it out.
So I did give you guys the packet, right?
Yeah.
Sorry to confuse you guys. I didn't. I guess I should have assumed that you would kind of flip through the whole packet. Kind of
Oh, I did
all
flip through it. I just didn't know what.
So you flipped through and saw that some were 4 and some were 18?
Yeah, that's why I was confused. I thought you'd like made it all bleeding from your lip and you were like didn't
Wow.
see what you're putting. Well,
Missing pages?
4.9, 4.10.
Oh, yes we are.
We only have 3 lessons in here.
No, I gotta add 2 more. I think it's because this is where I finished. I didn't get any further. Because I made the note packets like a couple of years ago, but I've gotten further before I made the note packets, if that makes sense. So I will have to make 18.2 and 18.3 note packets for you guys to add to your.
What class has gotten the furthest with the book?
All my classes that have gotten the furthest were my first year teaching,
Okay.
which is interesting how that is.
Do they usually get past last year's class?
Yes, last year was not, well,
Because you like them, so you talk more.
no, I think it was, actually, I think the past couple years, we haven't gotten, very far. And if you think about this is what, 3 days? So, 3 days further. I don't know how much further that is. And if you think about it, we didn't do the whole first 2 chapters.
Except that 17 was their final review. They had final review along with it, right?
No, I don't know if I reviewed.
Oh.
Probably, I mean, just, if it's a regular chapter test, that's true, then we probably just had one review in the study session. So, yes, we are going to do oxidation reduction, which unfortunately, I don't think we probably got to the oxidation reduction chapter in chemistry either. In fact, I've never gotten back to the oxidation reduction chapter in chemistry outside my first year. So, you're probably not super familiar with it. I'm assuming you read though, right? So basically what an oxidation reduction reaction is a type of reaction, just like if you remember the types like single replacement, double replacement, synthesis, decomposition, those were types of reactions. Acids and bases are types of reactions. They're called redox reactions, and basically what happens in an oxidation reduction reaction is 1 or more electrons will be transferred. Rusting is an oxidation or a redox reaction. A lot of batteries are oxidation or redox reactions. Many reactions that involve the production of energy or used as an energy source are actually redox reactions. It's basically the pumping of electrons from one position to the other, which you'll see as we progress through here. And a big part of oxidation reduction reactions are knowing oxidation numbers. Okay? You guys probably are familiar with those, though, correct? What's the oxidation number of magnesium? 2+. Okay, I figured. But I'll give you this because there's a couple things that we need to talk about because we didn't spend a ton of time when we did oxidation reduction reactions, or when we talked about oxidation numbers. We didn't talk about all of the, if you look over here on the periodic table, we didn't talk about all of the possible oxidation numbers here in nitrogen, right? We just said that all of group 15 is 3-, right? Okay? Well, the reason why we just dealt with that is because when we were specifically talking about oxidation numbers, they were used to write ionic formulas. So like I would look and I would go, oh, aluminum is 3+, and fluorine is 1-, and the purpose of that is so that we could find the formulas, okay? But for covalent, if you guys remember, the naming and writing formula system is different. They use the Greek prefixes. Do you remember that? So we never had to figure out oxidation numbers for nonmetals bonded with another nonmetal. Does that make sense? So that's why we never really got to talking about the rest of these, because the rest of these oxidation numbers are when you have covalent compounds, when you have two nonmetals bonding together. Because if you think about it, all of these nonmetals would have a negative charge, correct? So how are they going to get a positive oxidation number? And that's where we really kind of left off. We never really talked about that. So I've just given you guys some rules here. So let's quickly look at this. A free atom. This just means an atom by itself that doesn't have a charge. Now, quickly, what oxidation numbers are a way of bookkeeping electrons. Trying to be able to show when something's gained or lost electrons and whatnot. So since a free atom that doesn't have a charge is neutral, we give it a 0 for an oxidation number. If I have an ion, its charge is its oxidation number. So if I have an ion that is that's its charge, that's its oxidation number. Okay, that's not an overly difficult concept. Number 3, the oxidation number of a more electronegative atom in a molecule or a complex ion is the same as it would be if it were an ion. So this is where it kind of starts getting into those covalent guys. Because if you guys remember, if I say molecule, that's specifically talking about a covalently bonded compound. All right, so let's say I have NO. Let's see. We'll just go NO2. Make sure that that's actually possible. Yep. Okay. So if we look at this, we have two nonmetals. And based on this rule, it says the one that's more electronegative will retain its typical charge. So which one's more electronegative? Okay? So what is its typical charge? 2 minus. Okay? Now, this is a neutral molecule, which means overall it has no charge. So if we know that this is -2, what does this have to be? 4 plus, because I have 2 of them. Right? So 2 times 2 negative is 4 negative, so this has to be 4 plus. If you add those two together, you should get then a neutral atom. And if you look up here, does nitrogen have the ability to have a 4 plus charge? Yes. Okay. Another one. Let's do something like this. So this is a non-metal's bonded, but it's a polyatomic ion, so it has a charge. I think that's where 11 says. It says the sum of the oxidation numbers of the atoms in a polyatomic ion must equal the charge of the ion. So the sum of these two oxidation numbers must leave me with a 3 minus charge. Rule still applies. Which one's more electronegative? North Dakota, huh? I don't know how to mute that, but I don't want to answer that. Okay, so oxygen is still the more electronegative element. Its oxidation number is what? Minus. Okay. So what will phosphorus have to be for me to add the two oxidation numbers together to still get a -3 charge? 5 plus. Yes. Everybody see that? 5 plus 4 times -2 is -8. So -8 and +5 is 3 minus. And let's see if phosphorus can be 5 plus. I sure hope so.
Is there a reason why the plus is in front but the minus is
No, I just didn't write it right. That's fine.
yeah. I was just
It's just weird for me to write like that. I forget sometimes. Yeah, it should be like that. Okay. Any questions on that? What you need to do is figure out which one's the more electronegative, then apply that to that guy, and then just assume or figure out what the other one is based on if it has a charge or if it needs to be neutral. Not overly difficult, right? Okay. I'm gonna let you actually do a couple on your own just to make sure. As long as you do these 3. Got it already? Still working? Good? Okay, I don't think this is overly difficult. Let's just make sure that we have got it. Carter, what did you have? Okay, oxygen, 2 minus. Everybody good on that? 4 plus 2 minus? Okay, SF6. What's the sulfur? 6 plus. Fluorine is 1 minus. Okay, yep. Nitrogen here?
5 plus.
Yep. Oxygen? Good on that? Okay. That's important because when we're doing oxidation reduction reactions, we have to figure out their oxidation numbers. And it will get tricky, and when we start balancing redox reactions, that's where that's probably the lesson that's the most difficult, is because it's not as simple as, you know, just balancing the atoms, because you may balance the atoms without balancing the electrons, and that's where it can get tricky. But before we get there, we've got to be able to identify some stuff.
That's the next lesson.
Yeah.
Is that tomorrow or Wednesday?
It will not be tomorrow.
Okay.
Okay? Now, here's some vocabulary stuff. The object that gets oxidized is the one that loses electrons. Okay? Oxidation is the process of losing electrons. Reduction is the process of gaining electrons. I know it's kind of goofy because you're thinking, reducing? Why are we gaining electrons? Well, remember what the charge of the electrons is. Negative. So you're reducing the charge by adding electrons.
Yeah.
Okay, so don't get confused by that. You probably have never heard this since I never got to this chapter in regular chemistry. Leo the lion says, "Grr, lose electrons, oxidation." So if an object loses electrons, it's getting oxidized. Okay? The object that's gaining electrons is the one that's getting reduced. Because if you're gaining electrons, your charge is going down. You're reducing the charge. So, if you're having a hard time remembering oxidation is the one where you gain or you lose electrons, and reduction is the one where you gain electrons, think of Leo, the lion goes grr.
Sure.
Yeah, sure.
Sure.
Okay? Now, another thing here is they have oxidizing agent and reducing agent. The oxidizing agent is the guy that gets reduced. And the reducing agent is the guy that gets oxidized. And let me explain what I mean. The person that gets oxidized does the reducing, or reduces the other guy. Does that make sense? And the guy that gets reduced is the guy that's going to oxidize the other compound or element. So, just think of, if I ever ask you to identify who the oxidizing agent is or the reducing agent is, they're always opposite. So, if I find that something is oxidized, I will immediately assume that it is the reducing agent. And when I find something is reduced, I'm going to immediately call it the oxidizing agent, because it's going to oxidize the other thing. It's the agent that oxidizes. And I'll show you what I mean when we go through an example here. We're almost done, actually. So, okay, let's do this problem. So the first thing I want to do before we get into balancing these guys is being able to identify what is the guy that's being oxidized and what is the guy that's getting reduced. Okay? So let's start with this. Actually, before we do this one, I'm just going to give you one example. That way I can let you do one or two of these guys. So I'm just going to give you an example. I don't think this is in your notes anywhere. Okay? First thing we have to do when identifying the oxidation and reduction guys is we need to first identify oxidation numbers. So, okay, this one's a trickier one. First off, you're probably not going to know which of these two is more electronegative. Okay? But if you look at your oxidation rules, it says that hydrogen, where is that? Number 6, says hydrogen is usually 1+. Okay? Rarely are you going to see it 1-, and I don't think we'll even come across a situation where it is 1-. Okay? There are some things that are pretty much always what they are. Like fluorine's always a -1, oxygen's almost always -1. It depends. There's one situation where oxygen's always -2. There's a situation where it can be -1, but we might not even get to that problem.
Like groups 1 and 2.
Yep. 1+, always 1+, always 2+. So there's some things that are typically always that can usually help us. So that guy's gonna almost always be 1+, which means the carbon is okay, I'm just gonna write them above. This is a free atom. An element by itself. I know it's bonded to itself, but it's only oxygen. So this has an oxidation number of 0. We know that this is the more electronegative guy, and it's almost always -2, which makes this 4+. We know this is almost always -2, and then that makes sense because that's typically +1. Okay, now what you're going to do is you're going to look at the elements that have a different charge from one side to the other. Okay, so if you look at the carbons, notice they have different charges. If they do, I'm going to connect them. This is how I do it. Okay, and I went from 4- to 4+. Did it gain or lose electrons? Okay, yeah, it lost 8. So if it lost 8, is it oxidized or reduced? Oxidized. So I will say oxidation, and then I could also call it the what? Yep. Leo, loss, electrons, oxidation. Loses electrons, oxidation. That's a little better. Okay? So we see that the H's are the same. Make sense? But we've got oxygens that's different. Okay, I know you could go, oh, well, I could point to 2 things. Well, yeah, that's true. Just go to one of the 2, it doesn't matter. Okay, and it goes from 0 to 2-. So it gained electrons to lower its charge. So if it gains electrons, we would call it the guy that gets reduced or reduction. And we could say it is then the oxidizing agent. Okay, and what's difficult here is making sure that all the electrons are balanced, so the transmitting of or losing or gaining of electrons, making sure that it's all balanced, which we will do that Wednesday then. We'll balance these guys. There are 2 methods. One of them is actually quite difficult.
It's O2, so it's 4-, and the other is 2 times H2O, that's 4-, that's 8-, with 8+, the other one. I'm sure they got harder.
Yeah. They will. Okay? So there's one example. Let's do these 2 then. you want me to show you one more, or do you want to try to do both of these? What are your thoughts? You just want to do the last one, or do you want to try to do both of them? What do you prefer to do? One more? Okay. I will show one that's a little bit harder than the others. First one. What did you say?
Doing this example in the notes.
Yes.
Oh.
I'm going to do the first one, and then I'll have to do the second one. Okay, first step is to identify what? Oxidation numbers, okay? How do I do this, guy?
This is 1 line.
What was that?
This is 1 line.
It is?
No, 2 lines.
Yeah. Which makes this plus. Now, how about this O2?
0.
Free atoms, so it's 0. Which of these two do we know? Which makes this. Okay, we know that this one is, again, 2 minus. So sulfur has to be. Okay, looks like lead stays the same, so it doesn't get oxidized or reduced. Sulfur changes. From 2 minus to 4 plus. Gain or lose electrons? Okay. Lose of electrons makes it what? Oxidized. Slash. It is the agent that reduces whatever guy that we say is reduced. Okay? It looks like our oxygen is the one that gets. I can go to either of those oxygens, it doesn't really matter.
Is it usually oxygen if oxygen is in it?
It's very unlikely that it gets oxidized, but it could be not either.
Okay.
Like, the reason why it gets reduced here is because it's a free atom here and then it's bonded over here. Like, if I had 2 bonded ones, they're likely to be 2 minus and 2 minus and no change.
Okay.
But, yeah, I'm not going to say it's always going to be reduced, but it's never, I can't think of a time where it would ever be oxidized.
Okay.
0 to 2 minus.
Well, there would be 3 different oxidation
Boy, it's been a while since I've done this. I'm not sure. If that were the case, if you were just identifying which one got oxidized or which one got reduced, it doesn't matter which one you pointed to. It's likely that you'd have one that would get reduced and the other get oxidized. I don't think that's possible. And if you ever run across something like that, I would say that's probably. Hey, go. Oh. You say hi. Quiet. So, whoopsies. So, if you got go from 0 to minus 2, what happened to it?
It gains 2.
Okay, so reduced. Slash the what? Questions? Okay, why don't you guys do the last one to end the day? How'd it go, bud? Visual discrimination. Wow, that's a problem. and not be in the 100th percentile. So my son got 100% on his kindergarten readiness, but he's only the 99th percentile national.
Can you beat 100? Is it possible?
Yeah, there's probably multiple students they can't beat. There's only one. I don't know.
Time completed.
Good job, buddy. You're the top of your class. Good job. You got what? Good job. Mom, Dad, who, when? Good job.
He was freaking out this morning. He thought he had to take the test. I didn't know.
You thought you had to take the test.
Yeah. But we were just going over it.
Cool.
We're gonna have a picnic or something.
Cool.
I wanna go to the part that's big, like a house. That one. Is it the one that we sell?
I'll be home.
I also
No, I
want
do
to
have
caught up on.
Mommy,
I do
I'm
have
gonna
practice
go get a
tonight.
drink. I'm gonna go get a
Okay.
drink.
Love you.
I'm gonna get a drink.
Yeah.
So yeah, I don't think that this stuff is overly difficult. It will get more difficult on Wednesday when we have to balance electrons, not just atoms. Which seems like it's like, oh, that can't be that bad.
That's gonna be larger numbers, coefficients, right?
No,
Okay.
not necessarily.
It's less kind of tricky. You're not really tricky, you have to solve for lead on the products on class.
Dang it, I shouldn't have given you that chapter. That chapter 17 test. I didn't take my time and look. I could have given you the 17-18 final.
Wow.
So I got a study guide for both chapter 17 and 18.
Still do that.
It'd just be chapter 18.
I'm gonna have to change,
Or just have 17 to 18 final ones.
I'm gonna have to change the question in chapter 17.
Oh, they're word for word, okay. Yeah, I see, that's the problem, right, it's the same thing.
Which I could.
Just change the numbers around, change the answers.
Yeah.
So have you ever tested it in
No, we need test it.
Alright, what do you guys get?
Yeah, I want a good test.
Oh, that's what I want.
In the lead was a 4+, sorry, the lead was the,
Yeah, reduce, yep.
lead was,
It's the oxidized nitrogen goes from 2 plus to 0. Yep. Goes from 2 plus to 4 plus. Yep. Good job. Easy enough. Until Wednesday, I guess.
It's just weird that reduction